Morning everyone. I think I'll get started so we can keep the program running to time and things. I'm Scott. I work remotely in Bristol in the UK, which is kind of roughly about 100 miles west of London, just to give you a bit of context of where I've come from today. I'm an independent sort of contractor, freelancer, I'm really excited to be here in New York today, and really grateful for getting one of the first sessions so I can sort of get you all while you're caffeinated. So that's awesome. I thought I'd start off with sort of setting the scene and sort of saying who this sort of talk is for. Really, it's for developers. It's from an Android developer to developers. It's not really for security experts. And really, what I'm aiming to do is kind of concisely go through these kind of three areas of our kind of Android ecosystem. There's absolutely tons of new APIs and new services every year. I mean, this is one of the cool things about working in mobile. There's so much new stuff to play with. So the aim here of this talk is to really concisely break down what's been new from the last 12 months from these three areas from a security point of view. And the real aim is so you can go away with things that you can practically implement into your apps to make them more secure. The sort of the theme we'll see throughout with some of the sort of services and APIs we'll talk about is that you can't trust the client, you can't trust the environment your app is running in, and that's a key thing we'll see come up several times with some of the APIs we'll look at. We do the checks and we send stuff to our server, our secure server, and we do the verification there. We'll keep touching back on this kind of key kind of principle. But I wanted to start today with what you can use, what you can sort of start using straight away. There's some cool stuff in Oreo, but we're really quite far from that being the sort of the most the largest percentage of Android devices. So with what you can use today, what I'm thinking is minimum SDK 14. And really, that's the Google Play services. And what I wanted to start off with talking about that is the SafteyNet, which is part of the API, which been around for a little while. They've added some new APIs to this, and a load more documentation. The logo is completely unofficial. That's one that I created. This is my awesome design skills. This is the limit of it. I created this for one of my open source libraries. Back in the days when SafteyNet first came out, the sample code wasn't great. And now it's much vastly improved. So I'll talk you through some of these APIs. The first one I wanted to mention was the list harmful apps sort of API. And this is all based around verified apps. And so you might have seen with Oreo, Google Play Protect was announced, and this has been around for a little while. This is just Google re-emphasizing that they're doing sort of security checks on any apps that are uploaded to the Play Store. And something that's been on device for years is verified apps, and that was Google's way of security checking applications, APKs that have been installed that haven't come from the Play Store. So you can programmatically check if verified app is enabled. You can actually enable it via the SafteyNet API. And the key thing here is the idea is that the device technically is more trustworthy, or that's the idea if verified apps is enabled. But you can't, verified apps doesn't force users to uninstall malicious apps. And that's where this API list harmful apps I think is quite useful for that. So you could, if security of the device is very important to you, you could list if there's any potentially harmful apps that are installed, and you'd get a result back from here. Then you could decide what to do about that. If you're a banking app, you might decide that you wouldn't run on that device. If you're, it really is subjective and depends on your use case. You might log the user out. You might flag them as being a victim or potentially a victim of fraud. So I think that's quite a useful sort of API for that. Another one that's sort of to do with verifying whether the user is a human and not a robot is verified with reCAPTCHA. We're probably all familiar with that on the web and used it. And so you can do this in-app via the SafteyNet API. So the way this works is that you would register your app with at google.com.recapture. You'd get like a site key and a secret key. The site key is effectively like an app key which you have in your app, and you'd call this method with your site key, and that would sort of pop up this dialog or this sort of screen. And I've only ever seen it sort of. I'm not a robot, so I've only ever seen it just pop up this and not require any user interaction. So I don't know if if I was a bot, that you'd get that sort of screen where you pick an image, but it didn't sort of work for me in my testing. So this would run, then you'd get a response from SafteyNet with a a token result. And then the idea is that you send that to your server for verification. And on your server, you would just do a post request to the Recapture API to verify that result was a genuine and valid result. And that's where you use the secret key that you've got when you registered. So the why just to emphasize this is just that you do this on your server and not on the app, so your secret key and that doesn't live in the app. And this is all to do with the fact that now your server knows that app instance or that installation has if it comes back as success false, then you can restrict server resources and things like that. The next thing you can do with SafteyNet is you can call the lookup URI, which is basically like a programmatic access to safe browsing. So Google are really pushing safe browsing. Now it's we'll see in a couple of slides time, it's now part of Webview. But this has been, safe browsing has been in Chrome and Firefox for years now. We probably all have accidentally clicked on a dodgy link and got that sort of red screen. Now we have, programmatic access to that. So, we can check things to see if they have been flagged as containing like malware apps or potentially harmful apps, or anything that's been linked with social engineering. So that's your two kind of categories that you can look for. And so this is useful if your app is sharing sort of third-party or user-generated URLs and things like that. You could pop up a warning to the user if they detected some that visiting this URL may be potentially harmful. There is a usage limit of about 10,000 requests per day, which is obviously woeful for any large-scale app. But there is options to increase that from the Google Cloud Console. So I think it's a useful API. The last one in terms of SafteyNet I wanted to talk about was the attestation API, which was the first one when SafteyNet came out. It was just this API, and it was just the one that you had to call. And this is kind of the easiest and most robust way of validating the health of the device. So it's particularly good when from a security point of view. This has changed a little bit over the last 12 months or so, because now there's two different flags that you get back from this. And also, like I mentioned, the documentation around this has got hugely better. So I grabbed this table from the documentation, reduced it down a little bit for the slide, but I thought it was useful to share it because I know we can see the kind of statuses which would trip the flags and return falses or trues. The CTS profile match, these are the two flags like at the top, the headings. This was the original kind of flag that was there. This is the most secure, and then they released a like a basic integrity check. And I really like the fact that Google have done these two flags, particularly with the kind of the nod to like devices with with custom ROMs but that are not rooted. You can see the difference there. So it's nice that depending on your application and the security level you're going for, you can have some user flexibility there. But the key things I want to point out here is I've tried to bold here. So whether it's an emulator, whether there's signs of the system integrity is being compromised, is it rooted? And this one's particularly interesting. Signs of active attack, like API hooking, which is really difficult to actually detect in app. So I'm not really sure how SafteyNet are able to detect that. I guess because they have the Play services has more sort of low-level sort of system permissions. But so that's things like the exposed framework and Cydia, and so it's fairly straightforward to sort of use the exposed framework to hook API methods and return sort of malicious sort of responses. So the easy common one is checking for SSL pinning. Often is like a Boolean sort of check. Well, with the expose module, you can just disable that and return true always, that kind of thing. So you can detect this is going on with SafteyNet. I think it's pretty, which I think is pretty cool. So you call this, you call the attestation, the attest API, you get your response, and then guess what? You put it to your server and you validate it there. So this might seem a little daunting at first. There's a bit more steps for this one, but the key thing is this is a lot more difficult to compromise than it would be just sort of flipping a Boolean on the client side. So the idea here is you validate the message you get back. The message is a JWS message, but that's just it's just base 64 encoded. It's nothing sort of it's just JSON effectively. You validate the certificate chain of that. You call the Android device verification API, which is a poorly named API, but it basically just verifies that response that you got from the SafteyNet genuinely came from Google. And then once you kind of verified that it's a genuine message, then you go through and actually validate the contents of that message. And that's in that message you'll have your basic integrity and your CTS profile match flags, but you want to check the sort of metadata that's there. So that'll be like things like there's a timestamp, so you can sort of check that to make sure it's not like an earlier message, like in case it was a replay attack. You'll have like your API, your app ID and an APK checksum, as well as your certificate hash. So that's all things you can check to verify that this is not only is it a genuine message from SafteyNet, but also it's a message from your app. And this is all, the point of this is so you can say that this result, from SafteyNet is genuine, and then your server can make the decision whether to carry on trusting that app installation. That's the key point. There are Java and C# server examples and documentation, and I've definitely seen a third-party PHP one. And I'm working on a Firebase Cloud Functions sort of service that people can implement. So watch my Twitter for updates on that. But yes, it's quite straightforward to sort of implement this now. But yeah, it's definitely one to look at if you're looking, for detecting root and things like that. The other two sort of APIs that I wanted to talk about as part of the Google Play services was the FIDO UTF support. So this gives us support for these little hardware keys for a second factor auth basically. So this is the Uber key. This is the one I've sort of tested with, the one I own. And you can already do this, directly with your Google account and with like AWS. Now, as part of the Play services, because this API is available, we can add it to our apps very, very easily now. So we can register and authenticate these keys. They can be NFC keys like this one, or Bluetooth keys, which are kind of just coming out. So yeah, I think this is there's a really cool sample project there, definitely worth checking out. So I think it's just awesome that this is now part of Play services. This is minimum lollipop, but yeah, we could add this to our apps and enable that second factor auth a lot easier for people with these keys. The second thing you can do for two-factor auth is using the new SMS retriever API. So I'll just walk you quickly through this diagram. So the idea here is you obtain the user's phone number. Oh, this is totally stolen from the identity guidelines on this. But I thought it was so good that I wanted to sort of keep it the same. So you get the user's phone number. In an O, actually, you can get this programmatically with a new permission, which I'll cover later. But the idea here is you get the phone number, you send it to your server. Your server then you start listening for the SMS via the SMS retriever API, which is part of the Play services. So your server sends the SMS with whatever sort of Twilio or whatever kind of SMS gateway you use. You send the kind of your one-time passcode and then your app's signing certificate hash. And the reason you include that is so Play services knows where to sort of route that message. So it's not like Play services lets you listen to all the apps. It's only all the SMSs. It's just that SMSs with your hash in it that gets kind of routed to your API, your app that's listening. Then you sort of get that. You can take the You can access the SMS directly. Then you'd send that code up to your server for verification. And the key things why this is really useful is that you can do that authentication and verification of the phone number and the user. It's a much better UX than getting the user to sort of cut and paste that out of their SMSs. And if you want to do it in an automatic way, you'd need the read SMS permission, which is quite a dangerous and one that people don't enable that often. So you don't need that anymore. So I think this is quite a useful API for this. And I mentioned this and FIDO for things that will increase us using using two-factor auth and making it a lot easier for users to use. So let's talk about Oreo now. So it's easily my favorite dessert so far. I'm not sure if it's a dessert, but it's definitely tasty. And we'll quick fire through a bunch of these sort of new things. So the platform as a whole, like every Android version, gets stronger, gets more secure. So in the past, there's been a bunch of hardening to the user space. This version of Android, there was a target for the kernel space, so the kernel's been hardened, and the also developer options now requires a password or passcode to enable. So I think that's great. I mean, hopefully everyone in this room who's kind of interested in security has passcode and stuff on their phone, but I think it's a nod to realize that developer options does open up potential for attack on a device if an attacker gets hold of it. So now it's just an extra sort of layer of defense there. And install apps, installing unknown apps has changed and got more granular. So it used to be you had this allow unknown sources, which was just like a checkbox for the whole device. Now it's done on more on a per app basis, that you can enable certain apps to be eligible to install apps from unknown sources. So I think this is the functionality generally unknown sources. I think it's an awesome thing from the Android platform. It lets you choose and have the freedom to use different alternate app stores. It's probably, on the flip side, it's probably the reason why we have more malware, more spyware and things on Android over iOS, because it's easy for users to install apps from dodgy places. But I still think it's a good thing. And now this in Oreo, you can just pick certain apps. So you can sort of say, like for me personally, I would have things like the Amazon app, Crashlytics Beta to be able to install apps, whereas I wouldn't have things like Chrome and email programs. So yeah, I think this is a nice change, and it would be nice, I guess, if people do want to install apps from websites, if you could restrict by certain sites. I guess that might come in Android P. But yeah, I think the point here is the platform's getting stronger. Updating the platform has always been that like massive security issue for Android devices. Devices languishing on older versions of Android. So these kind of three things make that process easier and quicker. So Project Treble, probably a lot of you familiar with that. The basic for this slide, just the point is that there's been separation between like the Android system and the vendor specific APIs. The net result is it's easier and quicker for people to OEMs to apply updates. So that's great. In Android N, we had updates that are installed to sort of mirror the system permission, partition. So this would be like installed in the background, and then when you restart the device, it was applied. So this works in the same way as Chrome and Chrome OS. So it's a great feature to get updates quicker. In O, it's now they use this marketing term streaming system updates. So that just means updates will be applied. You don't have to have as much free space to install it. Not all of us are lucky enough to have a 128 gig pixel. So in those lower end devices, this should mean that updates and security patches get installed quicker, and they're not waiting, and you don't get those out of space errors mid upgrade. And the last thing is that in Android O, as part of verified boot, you can't downgrade the OS anymore. And it's been like a common attack vector. If you find a vulnerability in an older version of an operating system, and the device is running a new one, you can just downgrade the OS and then exploit it. You can't do that anymore. But fortunately, and sort of hat tip to Google for this, you can disable this in developer options. So for us developers who have test devices and want to run different versions of the OS, you can still do that. But I think in general, that's that's the system being updated, making it updatable easier. And I think the other thing to mention here with updating, if you're trying to push your company or your team to increase that minimum SDK version, security is a good argument to make. If security is really important to you, you can justify reducing support or dropping support for those older devices, those older versions of Android, pushing your min SDK to 14 or even like 21 to sort of do that. So if you're looking, I'm sure a lot of us developers are all trying to raise that minimum SDK up. So yeah, security is a good argument to raise that. So let's cover some of the sort of features we can use as developers. Autofill, I had to mention it because it's like the number 2 kind of thing that came out in Oreo. If you look at the new features, and it's important from a security point of view, just because it means that more complex passwords will just be easier to sort of for users to use. It just works. That's why I kind of grabbed that GIF, because the idea is you don't have to do any work to enable this. You can give it hints with autofill hints, and you can flag stuff as not being important for autofill, and these are both programmatic, Java or XML based. And also you can add support to your own custom input UI if you need it. That's quite straightforward to do. I thought I'd mention, this probably will affect maybe like 1 or 2 people in the room. If you're developing an autofill service, so like Google have, like LastPass or OnePass, there's a lot of onus on the third-party developer, or a lot of onus on you if you're developing this, from a security point of view. Mark Murphy, who's in the room over here, has written a really good white paper on this auto follies, which I definitely recommend you look at. And that talks about some of the recommendations and some of the kind of pitfalls. The point here is that a malicious activity could potentially obtain data from an autofill service that the user isn't aware of. So you could have a hidden view that's off the screen that could suck down all your kind of address details or something like that, and all this data from your autofill service. So Google talk about like partitioning the data. So you say if you was an address field, to use that example, that you'd only ever supply address type information. If you could just return to the field in focus, which is kind of okay, but it kind of defeats the object, because autofill could fill the whole form in for you. You can get that information. And also they talk about only kind of giving back sensitive data to the app that provided it. So I think it's just something to think about if you're doing this kind of service. Also, and it's not kind of like unique to Android. I saw in iOS 11 some of the new features around their autofill, password autofill stuff, that they'd implement some new stuff in iOS 11 to sort of to lock this down. So only certain apps, only the app that provided the login details can get them. So it's not like, I'm sure in the next version of Android this will be kind of tightened up a bit. But yeah. The web view, it's one of those views that you either kind of love, hate, or hate, depending on where you're coming from. From a security point of view, it's always been the window to the internet and the window into your app, and there was tons of vulnerabilities and issues there. And one of the awesome things in Lollipop, they separated it from the OS, so you could get updates, every 6 weeks. It was bundled in the Play Store, so that was like a huge security win. They've separated it, and it runs in a different process. So again, isolating it is making it kind of more hardened and stronger. The other thing they've done is added safe browsing to it. So now very easily, so now it's very easy to sort of add safe browsing to it, web views in your app. So it's very simple to do. You just add this manifest tag to your this metadata tag, to your manifest file. Also, there's another metadata tag for your API key for safe browsing. But that's it, and it just works. It will automatically work on all your web views that you have in your app. And what's awesome, because it was bundled separately since Lollipop, but this works all the way back to Lollipop. So if you're using WebViews in your app, especially if you're loading URLs that are coming from third parties or that are not sort of known, it's certainly worth enabling this. Oh, the other thing as well, the web forms also support autofill. That's the other kind of addition to WebView. I thought I'd also just, there's a couple of networking changes, but I thought I'd just recap on the, from N, the network security config. This was the most exciting and cool thing about the last version of Android, and so I thought it was worth mentioning again. So with network security config, gave you like a platform official way of doing like secure networking, and this was all like via like a config file, like via an XML file. You didn't have to do any kind of coding. So you could do things like having a custom trust store. You could block any kind of clear text traffic, any non-HTTPS traffic from your apps. In Oreo, actually, that now supports Webview. It didn't for some reason in N. You could very easily do SSL pinning, and you could have like a debug-only config, which was useful if you had, say, like a self-signed certificate in development, or if you're kind of man-in-the-middle attacking your own apps, and when you're using a proxy, using like Charles Proxy or something to verify what you send to the server is what you expect. So it's useful having that debug-only config. I did a previous talk which kind of mentioned this, so I thought I'd link to that. But yeah, it's a cool API and worth looking at. So the kind of changes to sort of networking as a whole, they finally got rid of SSL version 3, awesome. And also now, if you're using HTTPS URL connection, it doesn't do any kind of insecure fallback, a TLS fallback. So this is kind of like, from an apps development point of view, the point is that it just makes your app's connection to your server a lot more difficult to man in the middle attack. So that that's good for us. I thought I'd mention a couple of new, I always say this word wrong, telephony, that's it, yeah. So there's a couple of new permissions, for programmatic access to phone numbers and answering phone calls. I thought I'd mention these. They're new, but it's nice the way we can sort of innovate and the system opens up more stuff for us. So these are obviously dangerous permissions. They're part of the phone permissions groups. The user's going to have to grant explicit access to these, but I think it's great. It gives us more options as developers for stuff we can do with our apps. There's also been a big focus on effectively, it's certainly privacy, but it's reducing the device identifiers, the hardware device identifiers. So this has been, the background of this is kind of oppressive regimes and things like that. Unfortunately, OEMs like Samsung still, add them back in, but from a kind of vanilla Android point of view, think in N, we lost access to things like the MAC address. And there's DNS access to DNS servers has been sort of restricted from system properties, but so there's a whole drive to reduce the reduce hardware identification. You'd be able to get at that in your app. So in the big one is the fact that the Android ID now is before Oreo it was just the same for every app. Now it's per signing key per user in each device. So I really like the fact that that Google opted for a signing key basis rather than a package name, because if you have a suite of apps, at least it might be important for you to know that these apps and this installation are all on the same device, and probably you're using the same signing key for those. So that's useful. And if you and the other thing that's changed is that if you ever used to get the hardware serial number from the build file, that's deprecated now, and you have to use the get serial method, and that's protected with the read phone state permission. So I think that it shows you the move to sort of use to not use hardware identification in your apps. And I thought I'd mention Android ID a bit, dive a little bit deeper on that, because if you are using it, it is changes you're going to have to make, or changes you will see. It won't change on uninstall and reinstall unless you change the signing keys, which is probably unlikely. But there's a kind of like edge case, certainly at the moment, what you'll probably see when you take an OTA update from 7 to 8, if your app's installed, you'll still get that same device ID that you had and you're used to, so it's backwards compatible. But if the user uninstalls the app and reinstalls it, they'll get that new scoped API, scoped ID. So that's an important thing to sort of note. And if you need to match those up, you can use the key value backup, which has been in the platform since Android 2.2, which allows you to store backups. Oh dear. I hadn't finished. So maybe someone's trying to tell me something. Anyway, that was kind of that was it for Oreo. A chance to take a drink. So the last area I wanted to cover was the Google Play Store, because there's been a huge kind of new update for that, which is in regards to app signing. So as you can see from the slide, this complex. I'll carry on because we have, we'll run out of time otherwise. But so app signing was traditionally you write your code, you build your app, you sign it with your private key, your key store, and that's then you upload that to the Play Store, and then the user installs it, and that's all the apps on Android have to be signed with a certificate. They have to be, and it kind of like a cornerstone of Android security is the fact that that signature has to be the same, like every single time. I can't take the Facebook app or the Twitter app, reverse engineer that, add some malware, and then if I duped you all into installing it today as part of the presentation, it wouldn't work because the signatures wouldn't match. I would have had to re-sign that. So there's this kind of, that's the way the system is at the moment. The massive, so you can kind of see it over there. So that's the process at the moment. So the major issue here is what happens if you lose your certificate, or what happens if it's compromised, your key store. And this happened to Google with the Android Authenticator app. If you ever used that, if you ever used the first version of that, it doesn't exist anymore because they lost the key to it and had to re-release it. And your only option is, because it's like mandated, and the way the system is that you'd have to create a new app. You'd have to, with a new sign-in key, a new app ID, and then persuade your users to move across. And we all probably know how difficult it is to get users to do stuff. So it's a very kind of like sticky situation, I guess, if you lose the key. And then the point is as well, Google can't do anything to help you with that. So this is where Google Play app signing comes in to sort of answer some of this, or at least help with this. And the way this process works, oh my God, we've got it back over here. Not that it really needs, obviously. Yeah. Oh, brilliant! It's almost like it was planned. So yeah, the idea here is you get an upload key. So you upload your sign-in key to the Play Store. Google give you this there's a little open source app that will encrypt it, so it's safe in transit, and then they keep that on their in a sort of a special secure server, a key management server. And the idea here is that you sign your code with your upload key. That's the sort of new key, and then the Play Store then re-signs it with your original sort of sign-in certificate, and then that's what's distributed to clients. So the key advantages of this is that upload key is revocable. It's not like just a quick revoke. You have to sort of apply to it via the Play Services support, and it takes a couple of days because they have to do verification and make sure that you're not just someone trying to take over the account. But the fact is, if you lose that key or it's compromised, or the developer that you've got working with goes AWOL, there's a path to sort of get it back. The there's a very streamlined migration. That the link below there is from an I/O video which talks about it. The second half of that actually is really interesting from the technical point of view. If you're interested in the security of the of what they do with your certificate, and the other thing this kind of opens up is that because the signing goes on the Play Store, it means Google can do some extra stuff with your APK. And the first one that they've sort of targeted is optimization of the APK size. So you can upload your just your universal APK, which may have all your resources for different different densities. And if you ever use native libraries, you'll have x86 libraries, you'll have ARM64, and they can take up lots of space. The app I'm working on at the moment has this, and there's each sort of library is around 10 meg, and if you're as a user having to download a 50 meg file when you actually only use like 10 of those, it's not optimal, not a great experience. And you can use ABI splits in Gradle to spit out different APK files, but it becomes a bit of a hassle when you're uploading it to the Play Store. So this is like an easy way of doing that. So you upload one universal APK, and that gets Google then do the optimization and spit out as many APKs as they need, and that's the one that users would install. And you can actually go and request the specific APKs that have been generated. They're not touching any of your code. They're just adding not adding. Hopefully, they're just removing files that a device doesn't support, so it doesn't need. So I think that's quite a nice gain of this. Before you kind of jump in and do this, you have to have a think about the fact that it's a permanent enrollment. There's no way to come back from this. If you want to go for App Store signing, you're in for keeps. You'd have to re-register if you're using your upload key hash, like with things like if you're using APIs like Firebase or Google Maps and stuff, where you have to register your key hash as part of the API security. You'll have a new key for your development stuff, your upload key. You have to re-register that. That's no big deal, but it's just something worth bearing in mind. And also, what about other app stores? You'll still have to manage a signing key for that. So if you're only ever going to release to Google Play, then fair play. But it's something just to think about how you manage that. So that's kind of most of the sort of presentation. I just thought I'd just do like an finally of what I want to see more of in sort of, or what for Android P, what can we, what would I like to see? And really it's, I was kind of excited about the network security config. I would love to see some more options for that. I guess I'm excited about it because I've done this the manual way, in code way, and I've talked about it in conferences before. And it's there's lots of things to do there. Now with network security config, it's easy to do. It's straightforward, and it's platform supported. So I'd love to be able to set the Cypher Suite versions and the TLS versions. That would be a cool new addition. But like most of all, I'd love to see network security config in an official kind of support library. I know there's a Mark Murphy, who I mentioned earlier. He backported it for which works all the way to Android 4.2, I think. It's slightly different. You have to sort of apply it to your HTTP client, but it's still usable in the fact you can use the same config going forward for Android 4 and 5, 6, and then 7. But I'd love to. I think to get critical mass, to get people using it, it needs to be a support library. A lot of places won't touch it unless it's anointed by Google. So I'd love to see that in the next the next 12 months. So that's it. There's in the last 12 months there's tons of new stuff, and this was just literally trying to take a slice of that, which is just security related. So yeah, it's been an absolute privilege today speaking to you. Sorry about those kind of crazy issues, but yeah, please do tweet or email me if you have questions and stuff. I'll get back to you, or even better, like I'm at the conference, that's why I'm here. Come and speak to me. So thank you very much.